Welcome, dear students. Myself, Dr. Rajashree Dhua, Assistant Professor, EEE Department. Today, I am going to discuss about Unit 4, that is the energy management strategies of the subject electrical and hybrid vehicle with the subject code P602. This is a subject for the 6th semester students of EEE Department. Now, hybrid electric vehicles have proven to be a very promising solution to environmental pollution and fuel savings. The benefit of the solution basically is realized as the amount of fuel consumption is saved, which by itself represents a challenge to develop certain right energy management strategies, that is EMS. Because hybrid electric vehicles they have different power flow routes, so the energy management strategies are very important. A significant number of energy management strategies have already been proposed, which can be categorized to better classify the design and control contribution with an emphasis on fuel economy. Now, what are the different types of categorization? One is the offline EMS, wherein global optimization EMS and rule based EMS are presented, and the other one is the online EMS, under which the instantaneous optimization based EMS, predictive EMS, and learning based EMS are there. Numerous methods are introduced with the main focus on the presented scheme, and the basic principle of each approach will be elaborated, and we will also know what are the different advantages and disadvantages. Now, energy management it aims to obtain an optimal power split in view of complex driving conditions. It is commonly acknowledged that there is an improvement in the fuel economy. The complex configuration and behavior of the multi-sort hybrid energy system introduces challenges to the performance of the energy management system. Regardless of the topology of the powertrain, the EMS aim is to instantaneously manage the power flows from the energy converter to obtain the control objective. The control objective will be reducing the emission, reducing the fuel consumption, and improving the overall efficiency of the vehicle. Contrary to pure electric and fuel vehicles, the HEVs are having various power sources, and therefore it complicates the structural layout. And HEVs have demonstrated a significant improvement in vehicle fuel economy and emission reduction while meeting the power requirements. As the technologies have gradually advanced, what we do is that we categorize the energy management strategies into three main parts: rule based, optimization based, and learning based. Let us now classify them in the following figure. With increasing environmental problems also, rising greenhouse gases and global warming, the need of clean energy sources is needed, and that's why we are moving towards electric vehicles and hybrid electric vehicles. And to control the overall performance of the hybrid electric vehicles, we need the energy management strategies. So, EMS is an essential challenge in EAV's design procedure to deal with the power distribution in multiple power source systems to improvement for the improvement of the performance of the HEVs. Now, the major task of EMS is what? Is controlling and organizing the power flows, energy storage, and power generation between the subsystems in order to save as much energy as possible. And the final goal of the EMS is to attain lower emissions and fuel consumption so that all the energy needs are met. Now, this is the basic classification. So, what we have the rule based strategies, we have the optimization based strategies. Under rule based strategies, we have definitive rules and we have fuzzy rules. Under definitive rules, we have state machine method, power following method, and thermostat control method. And under fuzzy rules, we have conventional fuzzy, adaptive fuzzy, and predictive fuzzy. Under the optimization based category, we have instantaneous optimization, under which we have model prediction control, contra agents minimum principle, equivalent consumption minimization strategy. And under global optimization, we have game theory, linear optimization, dynamic programming, genetic algorithm, and particle smoke optimization. And under the learning based energy management strategies, which are having the concept of deep learning, supervised learning, and reinforcement based learning. So this is how we basically categorized. And this rule based energy management strategies, they are static in nature, while optimization based and learning based strategies, they are basically dynamic in nature. So this is the overview of how the energy management strategies are categorized. Now coming to the deterministic rule-based strategies. What we do in this method, the control rules are performed by using certain if-then or lookup tables. A set of logical criteria is specified to share the power between the motor and the engine by taking into account the performance of the engine and the motor, as well as determining the static value of the threshold. And this method, it does not have any reliance on some mathematical model, and it is quite simple, leads to simplicity in implementation, reliability. And therefore what we do is that we have started with the rule based energy management strategies in the initial stage, and these are classified as state machine based control, thermostat control, and power forward control. Now, what is thermostat control? The fundamental principle of thermostat control strategy takes into account few of the input variables. Now, what are the input variables? Input variables will be vehicle velocity, the torque, the speed information, and the battery SOC. So, all these are basically input variables. So, the fundamental principle of thermostat strategy is that whenever the battery SOC it becomes lower than the predefined low threshold value, the engine now starts to work and produces some fixed power at the lowest point of fuel usage. While a portion of the power is utilized to drive the vehicle, the other portion is employed for battery charging. Now, when the battery SOC exceeds the high threshold value, the engine is now switched off and the motor only supplies the vehicle's necessary power. And power follower control strategy does what? This is a common technique that converts the thermostat control strategy into a modern practical approach. What is the difference is that in the thermostat strategy, only the SOC was the input variable that basically controls the engine start and stop. The power follower strategy makes this decision based on both SOC value and vehicle's power requirement. And state machine based strategy was basically it was a state machine mathematical model that was developed and built by Babbage, implementing power distribution by executing certain predefined control rules. And what we do in this strategy is that the maximum power was extracted through the electric motor to drive the vehicle, while the rest of the power is provided by the engine. Because in the hybrid electric vehicle, we know that there is a battery source or any energy source, and there is the IC engine generator set. So this is basically what the rule-based strategies in the deterministic rule-based strategies are concerned. And then we have the fuzzy logic based strategy. So it is a fuzzy logic based non-linear control technique that helps reduce the difficulty of control problems in non-linear time varying system. The three steps of fuzzy logic based strategy is fuzzification, inference, and defuzzification. The control input shifts from the numerical values to linguistic fuzzy variables during the fuzzification phase. The power sharing ratio is then determined using a suitable membership function that is dependent on the input fuzzy variables. Robustness and adaptability and against uncertainty, noise and disturbance are produced through the fuzzification process. And then what the defuzzification process does, it actually converts the variables back to the numerical form. So, early fuzzy logic based control strategies, abbreviated as FLRCS, frequently separated the operation phase and the calculation of calculated power distribution output by using fuzzy reasoning. And what are the input variables? The state variables are the vehicle speed, vehicle demand, torque, and SOC. And certain modifications of the fuzzy logic based strategies are done by adaptive fuzzy and by predictive fuzzy. So these are actually modification of the conventional fuzzy logic based control strategies. So this is how the rule based control strategies are demonstrated for the vehicle's energy management.